For this problem, we're given h of s is equal to 27,000 s over s plus 300, and then we have s plus 9,000. We need to find the zero of this function, and from previous problems, we know that what is in our numerator is our zero if it's associated with the s, and then what's associated with our s in the denominator are our poles. So when we look at the numerator, we only have this s. We don't have anything else connected to it. We could say this is like s plus 0. And this is really what our 0 would look like. And so the 0 for this function will just be 0. Now we're asked what are the poles. The poles here are going to be this 9,000 and this 300. But the 300 is lower, so our P1 is 300, and our P2, which is the higher of the two, is 9,000. So when we write this in here, we have 300, and then we have 9,000. Now we need to find our k, which is the gain, and we're putting it in standard form. To find the gain k, we need to use this formula right here, where we have the 20 log base 10 and then the k naught. Now our k naught, we'll find it up here. The k naught, we could look right here for it, and then it's going to be, well, we take the constant right here out front, and that's included, so we have 27,000. If we had a z1, we would take this, but since we don't, we're just going to have a 1 here, and this is just going to be divided by our p's. And our total p, which is going to be these two together, is 2,700,000. So under here, we're going to plug in 2,700,000. We can obviously cancel out some of the zeros, and then we can say that the numerator, if we just multiply it by 100, we'll get the denominator. So inside of our calculator, we're going to do 20 log base 10, 1 over 100, and this is going to give us a k of negative 40. And so that's our a, b, and c done. We're now going to find our d and e. Unlike the previous problems, we are not to graph them. We are not plotting here. We need to find the magnitude of this transfer function at omega is equal to 100 rads per second. And so to find for this, we are going to look at the formulas provided, and we can see that this hj omega is similar to this hj omega. And so we could plug this in here. We know that the part out front is just going to be our k naught, and our k naught is 1 over 100. We found that right here. And then we are going to have a, well, we don't have a 0. So we're not going to be dealing with this stuff right here. If we did have a 0, we would have to deal with it. But this is just going to be 1. And then this is going to be divided by, we have a j omega. We know our j omega is 100 that's given to us. So we can have 100 out here. And then inside of here, we are going to have a 1 plus the j omega, which is 100. And this is all divided by our P1. And the P1 is 300. We found that in the part right here. And so this is going to be our equation. And now we can plug this into a calculator. And this is going to give us 7.5 times 10 to the negative fifth. And then if we write this out, it's going to be 0.0000. And then we can test this by saying if we 1, 2, 3, 4, 5. So that means that we just need to add our 75 here. And so this is going to be our final answer. 0 point, we have 4 zeros in here, and then we have 75. Now we need to solve for the angle part. And for the angle part, we are going to be using this part right here. And we're going to associate it with this over here. So we have our angle, we have 300 inside of here, and then we can set this equal to. We don't have a z1, so we're not going to be looking at this. We do have a 90 degrees though. We don't need to subtract it here, so it's just going to be 90 degrees. We do have our poles, so this is going to be a minus angle of tangent, -1. And then inside of here, we are going to have our omega, which is 300. It's given to us here for this problem. And it's divided by our P1. And our P1 is 300. However, we will have to modify this if we have more than just one P. So inside of here, we are going to have a plus our omega, which is 300, divided by our next P, which is 9,000. And this is going to give us 44 0.06, which we can say is approximately 45 degrees. I did make a slight mistake, and that is with part D. Now, what I wrote out would help us when we were to graph this, to plot the function. However, it's not going to give us the correct answer here. It's incorrect. Well, it's correct, but it's also an incorrect way to do it. If we were to do something like this, we would need to use this, ADB, because we need the straight line approximation, and it highlights that right here. So missing that, but now going back to it, we can say that our h, and then into here we have our j omega, and this is equal to 100 rads per second, and then this is equal to the 20 log base 10, and then inside of here we have our k naught. We found our k naught up here to be 1 over 100, so we'll have 1 over 100. We don't have a 0. We can see that our 0 is 0. So we're not going to be looking at this part, but we do need to look at these parts right here, and this is a plus, not a minus here, so we'll have a 100 in here, and then we have our minus 20 log base 10, and then inside of here we have also, these should be absolute value signs. We have a 1 plus our j omega. This is going to be the 100, and then so we'll have a j times 100, and this will be divided by our p1, which is 300, and then we have to do a minus 20 log base 10 of the next p, so we'll have a 1 plus j 100 over our p2, and our p2 is 9,000. And so this is going to be the proper equation. But there is some things to note, and that's since our omega is less than the pole's corner frequency, that means this is going to be 0, and this is going to be 0. We're going to be comparing the numerator up here, this is the omega, to the denominator, which is the pole. And again, since the numerator is smaller than our denominator, well, that means we can zero these out. And so we're just going to be left with all of this right here. And from this, we are going to get a negative 40 plus a 40. And so this is going to give us 0. And so the proper answer for this would be 0 dB. If we were to solve it like this, we wouldn't actually get dB as our unit, which is why this was wrong. We didn't have any units. And now that we've caught it, we were able to solve it the correct way.